All right, in this lesson, question 3 for a labor market equilibrium, we're going to put labor demand, and labor supply together, and we're going to use them to come up with the market wage. Okay, so I'm going to use Desmos this time. And the way you use Desmos is I'm going to copy the labor demand equation. And it's labor demand because it has a negative relationship, right? It shows a negative relationship between wages paid and employment demanded, right? So as the wage rises, unemployment falls. And that's what that negative sign means right there, right? And this right here is the labor supply equation, because as the wage rises more and more people enter the labor market because their reservation wages are being met, right? Now we got to fit it over here. So here's our labor demand equation, and here's our labor supply, right? And they're meeting somewhere all the way over here. So we have to change the settings on the x-axis, right? The x-axis is E. The y-axis is fine, right? Y-axis is fine here. We just need to change the scale here. So I'm going to click on the wrench here, and I'm going to increase E to, I don't know, 200. See what happens. Well, it looks like I need to go to maybe 500. Yeah, there we go. We got 500. That'll work. Okay, so we got labor demand and labor supply. I'm going to match the colors with Desmos. I'm going to match Desmos line colors with Map and Math. So I'm going to make both these black. Okay. All right, so let's read on and see what we have to answer here. The equilibrium number of low-skilled laborers who supply their labor and the number demanded by employers is found by solving for E after setting demand equal to supply, right? So real quick, this is W. This is the wage rate, the hourly wage rate. This is the employment level, right? And we can solve, we can find the equilibrium by setting these two equations equal to each other. And we can do that in Desmos here, right? So right here, I've got the two equations. I'm setting each equation. Let's see right here. We got to multiply that by E. We got to multiply this by E, right? So I have the right side of labor supply and have the left side of labor demand, right? And then I can do the algebra right here in Desmos. I'm going to add this to both sides. And I'm going to subtract that from both sides, right? I'm going to subtract that from both sides. And I don't have to do the arithmetic yet, right? So I'm adding this quantity to both sides because I want this negative 0.43E. I'm going to add that to positive 0.043E to make that basically zero. So I got to add it to both sides, right? And that's exactly what I do there. And then what I can do is I can use the distributive property. I can undo the distributive property by factoring out the E, right? I can factor out the employment level, right? And then, I mean, I'm not doing any arithmetic yet, right? And then what I can do is I can divide both sides of this equation by the coefficient of E, right? And the coefficient of E is that thing right there, right? Now I can get rid of the parentheses, right? And so E is equal to 315.914, right? 315.914. That's E. And we see that's the value here, right? 315.914. So I can solve it, right? I can solve it for E, right? So E here, E equals 315.914, right? Now, when I define E to be equal to this ratio of sums, right? When I define E to be equal to that, notice what happens. It plugs this value here, plugs that value there into E here, right? And it plugs it into E. And the result is the exact same number, right? 17.6956989,247, right? Both these numbers are the same. That means you've done it right, right? You've done the math correctly. When these two things give you the same wage rate, you've done the math correctly, right? So the number of low-skilled workers is 315.914. Let me check the decimal places up here. We want to use 2 decimal places. So we can make that 91, right? Okay, so the quantity of employees demanded is 315.91. The quantity of employees that supply their labor is 315.91, right? And then the wage rate is 17.70, right? 17.70 if we round to 2 decimal places, because that's a 5 in the third spot. That when we round to 2 decimal places, this 69 becomes 70, right? Okay, so I'm going to go ahead and undo this math. And just again, click on the intersection of the two. And I get the same exact answers, right? 315.91 and 17.70 if I round this to 2 decimal places, right? Now I'm going to show you a really cool trick in Desmos. I'm going to plug in values for E, and because E is on the x-axis, and this is a math program, to plug values of E into this, either one of these equations, I have to use the letter X, right? So X here is E, right? Now, if I plug in X equals 0, right? If I plug in X equals 0, I get the intercepts of 1.9, right? I get the intercept of 1.9 here, and the intercept of 31.28. You see that? Okay, so I'm saying when I say X equals 0, that means E equals 0, right? And 0 times this is 0. So that stuff in blue is 0. So the wage is 31.28. And that's this point right here, right? 31.28. When E is 0 or when X is 0, the point on the line is 31.28. When E is 0, all of that is 0, right? And we're left with 1.9, which is this point down here. When E is 0, the wage rate is 1.9, right? So this is gonna be cool. Let me change the settings of this. I'm gonna change this to black. I'm gonna change it to dash, and I'm gonna make it skinny, right? I'm not gonna have big dots. Okay. Cool. Now we can go down to answer these questions here. The maximum wage firms are willing to pay, this regarding the first laborer, right? Remember what labor demand is. Labor demand is evaluation of the employees a firm wishes to hire, right? And they value the employees not all the same. Some employees have really impressive training, experience, education that is key to job success, employment history, and impeccable references, right? Those kinds of employees are valued the most. They're generally going to be on the labor demand curve here, right? Where the value is the highest. The employees with the least impressive training, the least impressive experience, the least impressive education that signals one might be a great productive employee for the firm. They're going to have lower valuations, right, on the labor demand curve, right? So regarding this first laborer employed, the maximum wage firms are willing to pay is what? We got to change this X equals 0 to X equal 1, right? When X equals 1, right, we're on the labor demand curve at this point, X equal 1 or employment equals 1. And the wage they're willing to pay is 31.24, right? 31.24. Now I'm going to put in the equilibrium wage rate. The equilibrium wage rate was 17.70, right? I'm going to change this again to black dash line and thin, right? Thin line. Okay, so this right here, this height here is the equilibrium wage, right? Now the firm is willing to pay, that first employee $31.24 per hour. They're willing to pay up to that, right? But they only have to pay what? 17.7, right? They only have to pay 17.7, right? So, whoops. They only have to pay 17.7, sorry. Okay. Now, the lowest wage the labor is willing to accept, the lowest wage this worker is willing to accept is what? That's the labor supply curve, right? On the labor supply curve, we see that that first employee is willing to do the job for $1.95 an hour, right? So the first employee hired is willing to do the job for $1.95. Perhaps the reason why that is because this person has like 10 kids to feed, right? And maybe this person doesn't have much education, or maybe this person doesn't have very good training, or the experience this person has is not very appropriate for the job, right? Experience is different. They have experience in different functions than what the job needs to be performed, right? So maybe this person is in that situation and they have 10 kids to feed. They're willing to take the job for $1.95, right? Now, in either case, right, whether the firm's willing to pay that first employee hired $31.24, that most desperate of employees, workers, is willing to do the job for $1.95. If this person gets hired, right, and if this person is hired, firms win, right? Firms win because they're willing to pay $31.24, but they only have to pay $17.70, right? So that first employee hired provides employer surplus of 31.24 minus the 1770, right? So that hiring that first very productive worker, the most desired worker, provides the firm with a surplus of 31.24. Right. And then if this worker with a reservation of 1.95 is hired, right? If the laborer with a reservation of 1.95 is hired, that worker wins, right? Because the salary they get paid, the wage they get paid is $17.70 per hour, and they're willing to take the job for $1.95, right? So that worker would have a surplus of 15.75, right? I think I typed the wrong thing in here. Oh, I typed 31.24 in there. I needed to type the difference between 31.24 and 17.70, which is 13.54. There we go. Okay. So that's for the first laborer employed, right? Now, if they're the same person, if the person that has a value of 31.24 and is willing to do the job for $1.95, then the total surplus of hiring that first laborer would be 13.54 plus 15.75, right? We'd add those two together, right? But in labor economics, that first laborer hired, right? That first laborer hired with the highest valuation of the firm is probably this worker here, right? This worker here has the lowest reservation wage. The last person to supply their labor is probably not necessarily the last person to supply their labor is probably the first person the firm wants to hire, right? And then this first person hired down here with the lowest reservation wage is the first person to offer their services in this labor market. The one with the lowest reservation wage is probably the last person the firm wants to hire, right? So labor economics isn't, it looks a lot like product economics, right? Demand supply of products. The supply and demand for labor is different because we're talking about people, and people are infinitely different, right? The person with a reservation wage of $17.70, right, is going to be the marginal worker, but the most desired employee, perhaps, right? The first laborer hired is going to have a reservation of 1.95, but firm's only going to value that first worker at 17.70, right? So it kind of inverts this a little bit, right? So it looks like the supply and demand for products, but it's different because we have, humans are not boxes. Humans are not cups. Humans are not calculators, right? A cup sinks if you throw it in the lake. A sponge floats if you throw it in the lake. A human, if you throw it in the lake, it has to decide whether it's going to sink or swim, right? So I think you got to make sure you understand those differences between product markets and labor markets, right? Okay, we'll move on to the second laborer, right? The second laborer, we're going to change X to equal 2. So E is equal to 2, right? And when X equals to 2, we move down the labor demand equation slightly, right? And we move slightly up the labor supply curve, right? We're up the labor supply curve and we're going to be down slightly on the labor demand curve, right? So the maximum wage firms are willing to pay the second laborer is 31.194. We're going to round it to 2 decimal places, though. And that should be 31, right? 31.9. The second worker, the firm's willing to pay 31.9, right? Another way to think about this is you can think about, you're a firm, and if you don't have any employees are scarce to you, right? So when they're scarce, you're willing to pay a lot. When they're not scarce, you're willing to pay less, right? So you can think of maybe laborers that way. If you can't differentiate between laborers, if there's no way to tell the differences between how productive workers are, right? Because maybe their applications, for some reason, all look the same, right? They all have similar work histories. They all have similar education backgrounds. They all have similar training, right? If they all look the same, like in the Navy, for example, if a bunch of people get out of the Navy and they all went to nuclear power school and they all served on a ship for 4 years and they're all applying for a job at a nuclear power plant in Ohio, it's going to be really hard to tell the difference between the two, right? So in that regard, when you can't tell the differences between the applicants to a job, then what determines the slope of the labor demand curve is you got no employees and you're desperate to find some employees, you're willing to pay a lot of money, right? So when identical homogeneous employees are scarce, you're willing to pay a lot of money for them. When they're not scarce, you're not willing to pay a lot of money for them, right? So that's another way to think about labor demand, right? Okay, so the lowest wage the laborer is willing to accept, right? The second employee is willing to work for as low as $2 an hour, right? The wage that is paid, of course, is $17.70, the market wage, right? The firm surplus of the second employee is the difference between the wage they would be willing to pay that person minus the wage they get to pay that person, right? So we're just going to modify this to be 31.19. We're also going to modify this to be 2, right? So for that second worker, right? For that second worker, that second person hired, right? The firm is willing to pay 31.19, but only has to pay 1770. That worker is willing to do the job for $2, but gets paid 1770, right? Both that worker and that firm win when they exchange, when the laborer exchange his or her services for the employer's pay, right? When they make that voluntary exchange, they both win. The firm surplus of that second employee is 1349. The worker surplus of that second employee is 15.7, right? And we can continue doing that for the third laborer, right? So for the third laborer, right? That third laborer is going to be paid 1770. Firms, because labor is scarce, right? They're willing to pay 3 employees 31.15, right? And that third worker is willing to do the job for $2.05, right? So that third worker is willing to do the job for $2.05 per hour. The firm is willing to pay up to 31.15 to that labor because that third employee is either the third best candidate, right? So you're willing to pay that third best candidate a lot more than maybe the 10th place candidate, right? Or if labor is homogeneous, when you can only hire 3 employees, when you need to hire 3 employees, you're willing to pay up to $31.15 because 3 employees is relatively scarce to where you want to be, right? So there's 2 ways to kind of think about labor demand. So the wage they pay is 1770, right? Wage they pay is 1770. I need to change this to 31.15, and I need to change this down here to 2.05. So this calculates the firm surplus of hiring that third worker, 13.45. And this calculates the worker surplus, the surplus of that third worker, right? 15.65. Now we can continue doing that, right? We can continue doing that. We can do it for the 4th worker, right? We can do it for the 5th worker, the 6th worker, the 7th worker, the 8th worker, the 15th worker, right? The 25th worker, the 35th worker, right? The 45th worker. Sorry. The 150th worker, right? For that 150th worker, if the workers are indistinguishable, if they're homogeneous, if you can't tell the difference between them, right? 150 is still relatively scarce, right? If you can only hire, 250. If you can only hire 250 employees. Okay, so yeah, with if the firm can hire 250 homogeneous workers and can't tell the difference between them, 250 is still relatively scarce compared to the 315.81 that are hired at the equilibrium point, right? So they're still relatively scarce. So they're willing to pay these scarcer employees more money, right? They're willing to pay them up to $20.53, but they only have to pay 17.7, right? So the employer surplus is shrinking. The worker surplus is shrinking too, right? That the 250th worker has a reservation wage of 14.4, right? So they're only going to do the job. They're only going to accept the job if they get paid at least $14.40 per hour, right? So their surplus has shrank too because their reservation wage is 14.4. The market wage is 17.7, so their surplus has shrunk, right? So the marginal employee, right, the last worker hired, number 315.914, that last worker hired is the marginal employee. And the firm that hires that last worker is the marginal firm, right? So regarding the marginal employee hired by the marginal employer, right? Notice at this level of output, which is what, 300, what was it again? At this 315.91 employees, notice if I zoom in, right? The demand curve and the supply curve cross at the same point. So the most a firm is willing to pay equals the lowest wage that 315.91 employee is willing to accept. So there is no firm surplus and there is no consumer surplus at the marginal, at the point where the marginal worker and the marginal firm are determined, right? There's no surplus there, right? Because the maximum the firm is willing to pay is 1770, right? The lowest wage that last worker hired is willing to accept a job for is 1770. The wage that is paid is 1770. So the firm is indifferent from hiring or not hiring the worker. And this last worker hired is indifferent between accepting the job and not accepting the job, right? Because their surplus, both these surpluses are zero, right? Now, firm surplus can be computed by summing up the firm surplus at each laborer demanded, or by calculating the area of the triangle determined by the demand curve, right? And the equilibrium wage. So we can calculate the firm surplus. Firms are buying labor, right? They're demanding labor. Right? Firms are demanding labor. So let me move this out of the way. So firm surplus is the area of this triangle made by these three dots, right? Or the sum of the heights, right? Some of these heights. You can sum up all these heights. There's going to be about 315 of them, right? There's going to be 315 of these vertical heights. We can sum those, or we can just calculate the area of the curve, right? Area of the triangle. So the surplus here is the height of this point. The intercept is 31.28. We're going to subtract off the equilibrium wage, right? So the height of this point is 31.28 down here to 0, right? Down here to 0. The height of this point is 31.28, but we want the height from 17.7, right? So we have to subtract 31.28 and 17.7. So this is the height of that triangle, right? We're going to multiply it by the width of the triangle. So we start out at 0 and we end up out at 315.81, right? Let me do this. There we go. We're going to end up out here at 315.91, right? So the width of this triangle is 315.91 minus 0, right? Minus 0. Because we're coming from 0 out to here. So we don't even need the 0, right? We can actually just have it 315.91. Then we're divide that by 2, right? We're divide that by 2. And we get a firm surplus. we get a firm surplus equal to 2,145.03, right? Okay. Now, worker surplus, because this curve represents the reservation wages, right, of all the people in this labor market, right? The worker surplus is the area of this triangle. Right? It's the area of this triangle. So we got to subtract 17.7 from 1.9. That's the height of that lower triangle, right? We're going to multiply it by 315.91, right? Divided by 2. If we don't divide by 2, we get an area of a rectangle. We want the area of a rectangle. We want the area of a triangle. A triangle is half a rectangle, right? So the worker surplus is $2,495.69, right? Okay. Now, there's a debate, right? Some economists will argue for equity, and some will argue for efficiency. Efficiency is typically associated with libertarianism, free market, no government intervention, right? And the advocates for efficiency are ones that argue for efficiency, are arguing for a market unimpeded by government, not interfered in by government, right? So that's the efficiency argument, right? So if firm surplus measures the total benefit that accrues to employers for participating in this market, and worker surplus measures the benefit that accrues to employees for participating in this market, the total benefit to firms and employees is maximized when the quantity of labor equals, well, that's the equilibrium quantity, right? That's the equilibrium quantity. And the equilibrium quantity was what? 315.91, right? When the quantity of labor equals 315.91 and total benefits to firms and employees equals what? We got to add these two values up, right? So what I'm going to do is I'm just going to add these two. So this right here is the firm surplus. This here's the worker surplus. When I add them together, I get total surplus, right? I guess I got to type it 4640.72. Total surplus is the area inside these 3 points, right? It's the area inside these 3 points. The lower triangle is the worker surplus, and the upper triangle is the firm surplus, right? Now, efficiency is achieved when the demand wage and the supply wage both equal what? Well, when there's 150 employees, right? The demand on the wage on the demand curve and the wage on the supply curve don't equal each other, right? If employment is only 150, firms are willing to pay that 150th employee $24.83. That 150th employee is willing to do the job for $9.40, right? So if only 150 are employed, all these people want to be employed, right? At this market wage. And all these people here, right? The firm wants to hire these people at that wage, right? They want to hire people with these valuations at that wage. They want, and workers want with these reservation wages would love to work at that wage, right? So this triangle right here would represent deadweight loss, right? Deadweight loss. But what happens here is as employment gets bigger, right? as the employment number gets bigger, what happens to that deadweight loss? This little triangle here on the right. The height between these 2 points is getting smaller, and so is the area here, right? That area is getting smaller. So then we'll go to 300. So if 300 employees are hired, right? Then we have a very small deadweight loss here, right? A very small deadweight loss. This little area here, right? And the height between the price on the demand curve and the price on the supply curve are getting closer to each other, right? So efficiency is achieved when both the supply wage and when the demand wage and the supply wage both equal the market wage, 1770. And you can see that right here at this point if I zoom in, right? Okay, so if I zoom in, the demand wage and the supply wage are equal. Not true if this is 314, right? The demand wage and the supply wage are different. They're pretty close, but they're still different, right? This is 17.79 and this is 17.6, right? At 315, the demand wage is 1740, maybe 1730. And the supply wage is 1765, right? The reservation wage of the 315th employee is 17.65. So these numbers are very close, right? The wage rates are really close, right? But only at the equilibrium, right, does the demand wage and the supply wage both equal each other, right? And when that happens, the quantity of labor supplied will equal 315. 315.91, right? The equilibrium quantity. Right? That's the efficiency argument. Now, the equity argument is, suppose politicians say that the market clearing wage is too low, right? Poor people can't afford 1770 an hour, right? Especially in this inflation that we're seeing, right? So at this wage, 1770, poor people can't afford to live off 1770. Now, it's going to be different in a rural place in Georgia or a rural place in North Carolina, where you might only need $8 an hour, given the rents and the food prices of a really rural town. You may only need $7.70 an hour to live on. But in a place like New York, you probably need $25 an hour at minimum, depending on the number of kids you have, right? So you're going to need a lot more money in a place like New York than you would in a rural town in North Carolina or Idaho or Utah, right? So if the government imposes a minimum wage of, in my case, $24.49, I'm going to change this to Y. Well, no, I'll keep it at the X. I'll come down here. I'll get rid of the surplus calculations. I'll type Y equal to 24.49. Now, why did I use Y? Because Y is the vertical axis, right? Y is the vertical axis. And the vertical axis is the wage rate, right? So let me get rid of this. I'm going to hide that. Okay, so now I got my demand curve. I got my labor supply curve, and I got this minimum wage at 24.49, right? So the imposition of this 24.49 minimum wage means it's illegal to hire a low-skilled laborer for a wage that is below the 24.49, right? It's actually illegal to do that. And when I type that number, whoops, 1770. You got the number wrong here, right? This should be 1770, right? The market wage is 1770, right? I forgot my 170. Okay, so when I type this number in, I hit enter or submit. Notice what MyOpenMath does. It draws a line in through demand and supply, right? So wages can't get below this number. That's the lowest the wage can get, right? It's got to, the wage rate that is paid has got to be at least $24.49, right? Let me press submit to make sure that got read right. Yeah, 1770, right? Okay. Now, when the wage floor is imposed, the size of the labor force, that's the number of people who want a job at 24.49. The number of people who want a job at 24.49, here's the wage 24.49. This is the number of people who want a job at that wage rate. And the number of people that want a job at that wage rate is 451.8. Right? Now, the employment level is the number of employees firms hire. It's the quantity of labor supplied, right? So instead of hiring 315.91 workers at 1770, this law means firms had to pay 24.49 and are willing to hire only 157.91 workers, right? So this is the employment level, 157.91. Okay. The difference in these values is called unemployment, right? The difference in these values is not zero. It's not valued by everyone, especially those that are unemployed. Is not a shortage, it's a surplus, right, of labor. So we call that surplus labor unemployment, right? So the equity intervention decreases total surplus. And we know that because the quantity of labor that is hired is only 1 to 57.907, right? So only 157.907 employees are hired, right? These workers are no longer working in the labor market. These workers are no longer working in the labor market, right? These workers aren't being hired by firms, and these workers aren't supplying their labor to firms, right? These people are supplying their labor to the firm, and the firm is hiring those people, right? So it leaves this huge deadweight loss. So this equity intervention decreases total surplus, right? It decreases total surplus by this triangle. The area of this triangle is how much total surplus decreases by. And we call that deadweight loss, right? Now it says characterize the marginal employers, the employees, right? Who are the marginal employees here? Right? Who are they? Well, who's hired, right? The people that are hired are the most productive. And maybe the most productive are the people with the best vocational training or they went to the best high school, right? They're going to be the ones that are hired by the firms. Who's not going to be hired by the firm? Well, poor people, and poor people populate this part of the labor demand curve, right? Why are they on this part of the demand curve? Well, maybe they went to a really bad inner city public school where they didn't learn how to read or do mathematics, right? And their communication skills are not very good, right? Maybe they don't even speak English, and the firms need people to speak English, right? Because the customers are English, right? So poor people are probably going to populate this part of the labor demand curve, right? They didn't have a job before the intervention, and they don't have a job after the intervention. These people here are going to be what? Maybe middle income people that went to okay suburban public schools. The people that populate this part of the labor demand curve They're the ones that are the most highly sought after. Maybe they went to the best public schools or private schools, right? So these might be children of very, well-to-do parents. These might be kids of middle income parents. And these might be kids of single parents living in the inner city, right? They're gonna provide the least value, the least productivity to a firm. So they're not going to be hired before or after this intervention is put in place, right? The people who lose their jobs are the kids of middle income parents, right? Whose education wasn't as quite as good as the children of really rich people, right? Or well-to-do people in the upper middle classes, right? They're going to have better training, better educations, right? So this policy doesn't help the poor because they're still here on the demand curve, right? And it harms the middle income workers, right? It harms them because they lose their jobs. This line segment here models all the people who lost their job as a result of imposing $24.49 minimum wage, right?